We had a look at classes and object-oriented programming in the last module. In this module, we'll have a look behind the scenes of that, because it turns out that this class feature, this class keyword, is relatively new in JavaScript. The idea of working with objects and of having blueprints for these objects, as well as having dependencies with inheritance, is not new, however. So in this module, we'll have a look at how we did that in the past, because as you will see, it'll also help us understand the present and some of the pitfalls there a bit better. To be precise in this module, we'll have a look at, well, behind the scenes of classes and objects, as I mentioned. We'll explore constructor functions, which is a way of building objects based on blueprints without classes. It actually is what classes do behind the scenes. And we'll have a look at prototypes and a concept called prototypical inheritance, which is what the extends keyword, when you use inheritance with classes, does behind the scenes, basically. It's super important to understand the concepts taught in this module, because they are a core of JavaScript, will be subject of many JavaScript interviews, and every JavaScript developer should understand these concepts, since they're such an important part of the language and of the behind the scenes stuff that happens in the language. Let's start with constructor functions, and for this I have a brand new project, empty HTML file, which only imports app.js, because in this module we'll not build any kind of fancy app. Instead, we'll work with, well, the things behind classes, since we already saw how we can use classes in a real project in the last module. So we can create a class, person for example, as you learned. There you can add a field, name for example, which will be translated to a property when you create an object based on the class. You can have a constructor in here, where you could, for example, also add a property like this. And you can also have a method in here where you, for example, console log, hi, I am, and then you add this.name, and I am, this.age, years old. Of course, we could have used string interpolation here as well. This is something very basic, which we did before. And then, of course, we can instantiate this as often as we want by calling new, executing person as a function, and here we go. You could also accept the argument in the constructor and use that in there. Here, I'm working with hard-coded values only, and therefore, let's see what we get when we call greet here, save everything, and then load this page. And indeed, we see, hi, I'm Max, and I'm 30 years old. This is nothing new. This is how you use classes, and this is what we learned about in the last course module. Now, behind the scenes, classes utilize a concept that has been around in JavaScript for forever, basically, for a very long time. And that's the concept of constructor functions. And of course, we have a constructor function, a constructor method in a class. And as you will see, that is basically related to that concept of constructor functions. In the past in JavaScript, and still today in many scripts you see out there, or in scripts that need to run like that in older browsers, which don't support classes, you will see constructor functions instead of classes being used. Now, constructor functions are a special type of function that acts as a blueprint for objects, same as a class does, that can hold and set up properties and methods, just like a class, and that can then be created with the new keyword. So, of course, in modern browsers, in modern scripts, we typically work with a class. But behind the scenes, this class here would essentially be written as a function with the function keyword, with any name of your choice, in this case person, where still the convention is to use a capital character to make it clear that this function should not be called as a normal function, but together with the new keyword to be used as a constructor function, because indeed, with the new keyword, JavaScript will call this function differently than it normally would. And then, other than that, you write this as a regular function. And to replicate this class, you would have to set this age equal to 30 here, this name equal to Max, and this greet equal to another function, an anonymous function here, which holds that logic. By the way, if you're a little bit more experienced with JavaScript, you'll know that this here, assigning name and greet like this, is not exactly equivalent to name and greet set up like this here in the class, but for now it's the only way we can set it up, and it will for now have the same effect. I'll dive into how this is different and how it could be done in a different way later in this module. So for now, this would give us a person constructor function which we can execute to build such a person object. And indeed, that code down there can stay as it is, and if we then go back and reload this page, we got the exact same output as before, but now using a constructor function. Now let's understand what happens here. Of course, we can't expect that this function returns our object, right? Because we don't have any return keyword in there. It only returns our object because of that new keyword. If we wouldn't have new here, if we just call person like this, you will see that now if I repeat this, I get an error. Cannot read property greet of undefined, because we would be calling greet on person, and person on the other hand, well, indeed is undefined because we just execute the person function. This function returns nothing, so it returns no value. So no value is stored in this constant, and on no value, on undefined, we can't call greet. So calling person like this won't work because we effectively call it like a regular function. The fact that it starts with a capital character is just a convention, not something that changes something magically in JavaScript. Indeed, it's the new keyword that matters, and you could use a lowercase p here like that and it would still work. And I would have to rename that constant here though, otherwise we have a name clash, and it would just work. If I execute this again, it works as before. So the naming here really is just a convention which you should follow but which has no technical impact. It's the new keyword that matters. What the new keyword does behind the scenes, and that's effectively also what it does for classes, is it executes such a function. In there, it sets this equal to the object that's going to be created, so equal to an empty object initially, if you will. Then it adds all these properties to this empty object, and then it returns this. And this is this object. This is effectively what's happening here, you could say. This is what the new keyword does here behind the scenes when you call a function with it, with new. And that is a special scenario, a special feature provided by JavaScript using such a constructor function. So now that we understand a bit how constructor functions work and that the new keyword matters, let's understand how this function relates to this class then. In the end, this class here is just something we call syntactical sugar for this constructor function, because defining blueprints like this can be a bit cumbersome. It can be confusing that you write a normal function and suddenly it doesn't behave like a normal function because you use new. And especially if you're coming from a different programming language, you might be used to having classes. This is why classes were introduced, to give us an easier way of writing these blueprint definitions. Now, behind the scenes, classes also do more than just set up such constructor functions. They also help us with a concept called prototypes, into which I'll dive in this module as well. But generally, this class does just create something like that for us. Now, the constructor function we have inside of our class effectively allows us to define this class body, so all the instructions that should run when an object is created based on the blueprint inside of a class. Because in a constructor function like this, it's obvious that whenever we create a new object based on it, all the code in that function executes. So this is great for initializing it, for setting it up, for reaching out to some server, or doing whatever you want. In a class, you have no such place. Well, almost. You have that constructor function, this special method in there, to be precise, where everything you place in it also executes when this object gets created. So whatever goes into that constructor method here in your class is the same that would go into this person constructor function. Now, your methods created like this actually are treated a bit differently. That's something you should be aware of, and I'll come back to how they're treated differently in a second once we learn a bit more about another concept which is the concept of prototypes. Now what's up with that? There is this term, this concept called prototypes in JavaScript, and it's super, super important to JavaScript. It's been around forever, and JavaScript indeed is a prototype-based language which uses prototypical inheritance. So these are a lot of strange terms. What does it mean? Well, in the end, the class syntax, that's important to understand, just is syntactic sugar for the constructor functions and also for working with the prototypes. Because working with them can be confusing, classes make that easier, but it's still important to understand what they do. So constructor functions and these prototypes power JavaScript objects. But what are prototypes then? Consider this constructor function, as I just explained it, a function which we can call with new. The equivalent, roughly, would be such a class, where we then build a person, a concrete object, by calling that constructor function with the new keyword. Now, this object which we build based on that blueprint, based on that class, or this constructor function, has all the properties and all the methods defined in that constructor function. So coming back to this example, when we create a person based on this constructor function, this P object here has an age property, a name property, and a greet property, which holds a function, and therefore effectively that's a method, because all of that is defined in here. Now you learned about that idea of being able to inherit from other classes, and therefore this has to be possible for other constructor functions as well, in order to share functionality, to provide some methods or some properties which are available in all objects based on this class or constructor function, or some subclass or sub-constructor function in quotation marks, because that's not an actual term. In non-class-based JavaScript, and also in class-based JavaScript, but there it happens behind the scenes, this is implemented with the concept of prototypes. Every constructor function you build has a special prototype property, which is not added to the objects you create based on it, because it's not part of the function body, but a property of that function object. Keep in mind that functions are objects. And that prototype is there by default. You can also edit it, something we will do. And it is then automatically assigned as a prototype to the object which is created when you instantiate that constructor function. Now, a prototype is an object itself. They're objects, and every object has such a prototype. Okay, but what exactly is the idea behind a prototype? Why does every object have a prototype? It's how JavaScript shares code in the end. And you can think of prototype objects as fallback objects. Objects JavaScript has a look at if it searches for a certain property or method it can't find on the object it started looking at. Let's say we have a person object which has a name, property, and a greet method. And then you have some code which calls person say hello. Now clearly there is no say hello method in this person object, right? So normally we would expect this to fail, and it might fail if our prototype or the prototype of the prototype also does not have a say hello method, because that's what JavaScript will do. It will not fail immediately. Instead, as I said, every object in JavaScript has a prototype, and a prototype is basically a connected object which is used as a fallback object. So here we have a prototype, and as I said, a prototype is just another object. And by the way, in case you're wondering, yes, this prototype object also will have its own prototype, and I'll come back to this chain of prototypes a little bit later. But back to this prototype here. So this is the connected prototype to the person object, and this prototype object might have a say hello method. And if JavaScript tries to access a certain method or property and doesn't find it on an object, it automatically looks at the prototype object and looks for the property there. And if it doesn't find it there, it looks at the prototype of the prototype all the way until it reaches the end of that chain and didn't find that property or method anywhere. And in that case, For a property, it would return undefined. For a method, it would throw an error. So prototypes are in the end just connected objects which serve as fallback objects. Now that might sound confusing. Let me give you an example. If I console log p.toString, you will actually see that this does not yield an error, but that this works. If I reload here, you see this strange output. The exact output doesn't matter. The important thing is that we don't get an error. Just to prove that we should expect one, if I call toStr, which I know won't exist, and I then reload, I actually get an error. ToString is not a function, or toStr is not a function. So why does toString work? Because actually there is some kind of invisible base object, you could say, on which our object is based. Of course it's based on this constructor function, but this doesn't add a toString method. So our constructor function somehow seems to point at some other base class, some other base constructor function, which also kind of is called, or which kind of does something, which basically adds the toString method to our object, kind of. Well, indeed, toString is not added to the object though. If we log the entire object with everything that's in there, we see there are exactly 3 things in there, but there's this thing, the __proto___ property. Now that's a special property, hence the strange name. It's not really a property you should use to assign a value to, though it would work, but not really recommended. But it shows you what this so-called prototype of this object is. And you can think of the prototype kind of as the base class. So a related, a connected object to which we can also reach out to ask it for properties or methods which you're trying to access, which don't exist on this object itself. For example, with toString. If we don't find the toString method in this object itself, which clearly is the case, JavaScript will go to that prototype, so to this object, and look into that. If we expand that, here we don't see anything. We see another object which has a constructor method. That's a function, right? So it's a constructor method, okay. But then this also has a prototype. And then JavaScript goes to that prototype and oh, here we have a more complex object. And there, for example, we see the toString method and a couple of other methods. Now actually that's the base prototype. This object here is a base object. Every object you create is based on, in the end, if you go down that prototype chain. The concept of that prototype chain is indeed very important, so I want to dive into that again. The idea is that when you build a blueprint with a constructor function or with a class, which in the end just uses constructor functions and prototypes behind the scenes, and you then build an object based on that constructor function, you can call a method on that object. Now let's say we're calling the breathe method here on person, and let's say our constructor function or class does not have a breathe method. What JavaScript then does is, it first of all, when we call breathe, it checks, is that part of the object itself? So was it defined in the blueprint? Because as you learned, when you then instantiate an object based on the blueprint, the object has everything defined in the blueprint. So is the breathe method part of the person itself, of that object which we created based on the constructor function? If yes, then we can execute the method. If no, well then we look to the prototype. And that's just something you can memorize. It's called prototype. It's basically a base class of this person object here in the end, you could say. There is a connection which is automatically set up, and every object you create by default has such a prototype, even if you haven't set up any inheritance here. So then this prototype is checked, the object, which is the prototype, is checked. Does that have a breathe method? And if the answer is yes, we're done. If not, we continue. We go to the prototype of the prototype, so to the base class of the base class of our object, so to say, check for the breathe method there, and we do that until we reach the end. And the last prototype we check is the prototype of this special object thing, which I also showed you earlier. So let's understand this prototype thing a bit better. Here in the code, there seems to be this object prototype thing, which in the end is connected. Let's ignore that for a second. Let's instead output p dot underscore underscore, so double underscore, therefore also often called dunder for double under, proto double underscore. If we do that and we reload, we get this object which has a constructor method and then also the underscore underscore proto underscore underscore property, which points at yet another object. This object here, which we're seeing here with these two properties, or with this one method and the proto property, this is the default object every custom constructor function assigns to an object based on it. And let me now show you how you can tweak that prototype. Every constructor function here, or every function in general in JavaScript, is in the end stored as an object, right? In the end, a function is just an object. Therefore, just as on any other object, you can assign properties by using the name of that object, in this case, the name of the function, person. And just to prove this, if I console dir this to look into it here, before we do anything, if we do that, you see, this is the function object, and in the end, it has this special way of being displayed here, but you see it has a bunch of properties, the arguments property you learned about earlier, it has a name property, it has a proto underscore underscore proto property, and it also has a property which our other object does not have, it has a prototype. Now that can be confusing, having underscore underscore proto and prototype. In short, underscore underscore proto is present on every object in JavaScript, no matter how you created it. No matter if that is a function object which we use as a constructor function, an object you built with object literal notation, an object you built with the help of a constructor function, an array, you always have underscore underscore proto, because this shows you the connected prototype. So this backup object, if you want to call it like this object is connected to. Now, prototype sounds similar, but does something totally different. This prototype property does not exist on every object. It exists on function objects. Because JavaScript is a prototype-based language, we use constructor functions to build objects, and whatever you set here on prototype will be assigned as a prototype to any object that's built based on this constructor function. And therefore, indeed, we see that what's set to prototype here is an object with a constructor method and also, of course, the underscore underscore proto property. So, in short, the exact same object we're logging down here. This here is exactly the same object, constructor function, and then proto down there. It's exactly the same. And indeed, that's true. If we compare our object, our person object, what is set up as a prototype there, to person.prototype, then you will see that if I reload here, we log true. So these are exactly the same objects, not copies, exactly the same object in memory. Now, this does not mean that our constructor function object and this person object have the same fallback object. They don't, because that's stored in the underscore underscore proto property. Prototype is not what this function object would reach out to if we call something on it like toString, which we can't find on the object itself. This is not what prototype is there for. This would be handled with the prototype being used as a fallback value for this constructor function object. Instead, the prototype property, and I know it's confusing, it's just how these properties are named, unfortunately. The prototype property of our function object instead can be used to assign an object which then will be assigned as a prototype, so as a fallback value, to any objects you build based on this constructor function. So here, for example, we can set prototype to a new object with, let's say, a method of print age, where we then say console log this age. So now what I do here is I set that every object we build based on this constructor function should have a prototype which is exactly this object. The result of that is that if I now log p dot underscore underscore proto, I see this object here indeed. And therefore, we can, for example, also call p dot print age. Not because there would be a print age method set up directly in the constructor function, it isn't, but we set it up on our fallback object. And therefore, this works. If I now go back and I reload, you see 30 being printed here. That's also important that this keyword inside of your prototypes always refers to your object on which you called the method. And that makes sense, right? You learned that this refers to whatever called the method. And that is also something you learned in the last module when I talked about inheritance. What's set up there in the base class, when you use this in some method of the base class, if you then call it on the object that's based on a subclass, this in the base class will refer to the concrete object on which you called it, not on the base class itself or anything like that. And indeed, prototypes here, that's in the end what class and extends do for you. When you create a class that extends something, you in the end inform JavaScript that you want to set the prototype to a new object or add some new methods and properties to that prototype, to be precise. So what I do manually here is done for you when you extend something here. And I can prove this to you, of course. If we comment this out again here, all of that, and we comment back in that class here, and we now add another class up there, aged person, I don't know, something like that. And in there, I add this print age method where I just console log this age. And now I here extend the aged person. And I change nothing else. If I now go back to my code, or to my page, and reload this, well, I get an error regarding the constructor, the base class constructor not being called. If we added our own constructor, we need to do that as you learned. So let's add this here in the person class. And now you see I get basically the same output as before. And when I output my person prototype here, you indeed see that is my aged person. The only difference to the output before is that indeed I still have that constructor property. And I'll show you why that is the case in a second. Now, what can be confusing here is that here you actually see the greet method though. So the prototype seems to be aged person, but where is our print age method then? Well, actually, if you expand the prototype of the prototype, so the fallback object of the fallback object of your person, so to say, there you will find print age. Now, the reason for this double prototype structure, which class with extends creates here, which clearly differs from what we got with our constructor function and just person prototype, will be explained a little bit later in this module. It has to do with how JavaScript adds methods to our objects. It does this a bit differently with classes than it does that with a constructor function here. But again, I'll come back to that. For the moment, we can still keep in mind that in the end, extends, when we use classes and we use the extends keyword, still works with prototypes to make functionality available on all classes that extend the same base class. But other than that, what happened is that the prototype of our person object was set to this object here, so to say, to an object based on this class here. And this also explains why you have to call super. In the end, what this does is it creates an object based on this class and then sets it as a prototype to the object built based on this class. That's also what we did manually here, right? If I comment this back in and comment this here out again, then what I do here is I create a concrete object and set it as a prototype for person so that when I create an object based on that, I have it available. And that's the same thing here. In the constructor of the object, of the person object, so to say, I have to create a aged person object first so that this can be set as a prototype for the to be created object that's based on person thereafter. So it's the same, just with, of course, some syntactic sugar, which is easier to understand than this code down there. But this is in the end what happens behind the scenes. Now what's strange here, or what can be strange, is that if I now reload, this was my old output when I used a class with extends, we see that now the prototype is back to an object which has proto and printH, but not the constructor method. Well, that happens because what I do here when I assign a new prototype is I replace the old default object which is assigned as a prototype with a new object. A better approach therefore typically is to not replace it, but instead reach out to prototype and dynamically add a new property or method by adding a dot and then the name of your property. And then here, this can of course be a function. So I can now copy that here, add the function keyword, and then add it like this. And the result of that will be that if we now save this, and now I reload, you see here, I also now have an object which still has this constructor method. By the way, in case you're wondering, this method here refers to this constructor function. So you could create more objects of that type by saying const p2 equal to p underscore underscore proto constructor like that, and add the new keyword. If you do this here, you will get a new person object, as you can see if you reload. But of course, that's a very complex way of doing that here. It can be useful in apps where you somehow don't have access to the constructor function anymore. Here we do, and therefore this, instead of just new person, of course makes no sense. But it can make sense if you don't have direct access to the original constructor function anymore. So that's what the constructor method points to. More importantly, this is how you typically want to edit the prototype so that you don't overwrite the default one and hence you keep the constructor method, but instead you just add what you want to add. Now it is important to understand that the prototype chain does not end after reaching out to that prototype of that person object. If we try to call a method like printH, which is not part of the person object itself, because we don't set it up in the constructor function, and we didn't add it to the person thereafter either, well then we go back to the fallback object, which is the prototype, right? So it's this prototype here, which indeed has the printH method. If we call something else, for example, if I try to console log p.to string, the question is, will this now still work? It worked earlier because we could fall back to an object, a base object, which had the toString method. The question is that still the case now that we kind of edited the prototype here? Well, let's see. Let's save it and reload, and yes, it still works. We get no error. Now, it still works because the prototype chain doesn't end at this default prototype. If we have a look at our prototype, it's this function, or this object, excuse me, which has the printH method and the constructor method, but which itself also has a prototype. As I mentioned, every object has a prototype, not just the object we built based on a constructor function, but also the fallback object of our object, so the prototype of our object. That prototype, that fallback object, has its own fallback object, its own prototype, and we can reach out to it with the special underscore underscore proto underscore underscore property here. If we expand it here, we see an object which has that toString method. The question just is, where is this object coming from? This, in the end, is the base object you always have access to. The default prototype every object gets, thanks to it being assigned as a default to be assigned prototype on every constructor function, can be found on the global object class, or to be precise, object constructor function. If I console log object like this is globally available in JavaScript. This is a constructor function that's built into JavaScript, so to say. If I console log that, maybe at the bottom, and get rid of that p2 log, if I console log that, you'll see that this is in the end, well, something like that. Let's try console.dir here if we can look into it. Well, yes, we can. But in there, you'll find a bunch of interesting things, but toString is not part of it. Instead, this has its own prototype. But again, no toString in there. In its prototype, we find toString somewhere though. But that's actually not the reason why we have access to toString here on our person. Instead, object here is a constructor function with a bunch of built-in properties or methods you can call. In the class-based world, we would call these properties and methods, which you can call without instantiating an object based on that constructor function, static properties and static methods. So everything you see here, in the end, are just static methods and static properties of that object constructor function. And indeed, when you go to your class and you add a static property, this simply means that a property is added directly here to your constructor function object. So it is as if you go to person, which is a function, but which therefore also is an object, and you add describe to it and say that this is a function where you want to describe what this function does, for example, creating persons. Now, this is a property of the person object. It's not a property that will be added to objects created based on the constructor function. There, we only add what's inside the constructor function. This does not tweak the function body or anything like that. Instead, it interacts with that function object which is created. And even though it's not that common, of course, you can add properties and methods to that object as well. Again, this has no impact on what executes in the function body. It's just something you can interact with on the function object itself. So if I add describe like this, indeed, if we build a new person and we console log the entire person object down there like that, you will see that if I reload here, our person has no describe method. My function, which I log up there, however, has a describe method. So it's really added on the function object itself. And object here, this globally available constructor function, has a bunch of such predefined static methods and properties. But the important thing is that object itself is not the fallback object, the fallback prototype all other objects can come back to in the end. If it would be, then we should be able to, for example, call length and get a value of 1 on any object of our choice. So I should be able to reach out to p.length and print a length of exactly 1. Because a length property does not exist on person, so it should go to its fallback value, this prototype. There it also won't exist, and therefore it should go to the fallback value of this object. And if that were object, so this global object here, then this should print 1. But as you will see instead, if I reload here, it prints undefined. Because, as I mentioned, this global object constructor function is not the fallback object of everything. Instead, and that can be confusing at first, the fallback value of all objects is object.prototype. Again, because of this property naming, it can be confusing, but keep in mind that this prototype property exists on everything which is a constructor function, and object is just such a constructor function in the end. It defines what will be assigned as a prototype to any object that is created based on this constructor function. Therefore, any object created based on person receives the default prototype with the print age function added. Every object created based on this object constructor function, this built-in object constructor function, receives its default prototype. And it's this default prototype, if we have a look at it, that indeed has the toString method and a couple of other methods. So this is really just configuring which default fallback is assigned to objects that are created based on the object constructor. And there it's just important to know that this fallback object here, for the person constructor function, this default prototype you get here, or any object you create on your own with the object literal notation, for example, by default always uses this global object constructor. So any object created with the object literal notation or the object created by JavaScript automatically as a default prototype here will be based on this object constructor function and will therefore use this prototype as its fallback value. So every object by default uses this as its fallback value, including the default prototype object you get for your own constructor functions. This is how that is connected. Now, in case you're wondering, this prototype itself then has no other prototype. You will not find any __ proto method here, just a getter and a setter, but this won't do anything. It will basically just capture any interactions, because if you try to get the prototype of that base prototype of everything, you will see that if I now reload this, it just prints null. So that's where the prototype chain ends. It ends at object.prototype. Now, I know that this prototype stuff can be very confusing, also because the naming is so similar. But it's really important to understand the difference between the prototype property on constructor functions, where you configure what will be added to objects that are created based on that constructor function, and the __ proto property, which is available on every object, not just on constructor functions or function objects, which in the end points to the prototype that has been assigned to this object. So to the fallback object that has been assigned to that object. That is really important to understand. And that's the idea behind prototypes. Now, arguably, using classes and extending makes it a lot easier, which is why we have that and why we use that. But it is super important to understand this behind the scenes stuff, because JavaScript is based on it. And not only will you find this in many interviews, or will you be forced to use this in code because you can't use classes for whatever reason, it also helps you understand the code you write. And it's such a core concept of JavaScript, has been around forever, you gotta know it. Now, there also are some specialties related to that concept. And I mentioned earlier that this constructor function is actually not a perfect replacement for this class here. And thus far, we didn't know how to write it in a better way. Now we do. Because actually, everything which you have in the constructor, except for that super thing, which is especially in classes, everything you have in the constructor of a class can go in a constructor function, and you have exactly the same behavior. Every field which you set up will also be added just as if you would have written it in the constructor. Only important thing here is it will automatically be added after any super call you might have in there, because you have to use this, and using a field effectively will create it as an instance property, will set it up as an instance property using this after calling super. So fields effectively are translated to properties just as if you would use that in constructor syntax. Here, for example, with this age, you could do the same for this name and would have the same behavior as you have when you add a field. There is a difference between constructor functions and classes, though, if we have a look at how methods are added. For example, this greet method. Let's see what the difference could be. I'll comment out all that code at the bottom, comment out this constructor function and my prototype editing, and comment back in this class here. Now let's go down to the bottom and again create a person with new person and console log that person. If we reload this, we see this is the object that was created with the prototype, which also has the greet method. Wait a second. A prototype which has the greet method? Where is that coming from? Shouldn't the greet method be part of the object itself? I defined it here in person. Aged person should only add the print age method and nothing else. Well, turns out this is in the prototype of aged person, not in the prototype of person. So we have an extra prototype that was added by JavaScript when we worked with classes. But that's interesting. Name, on the other hand, indeed was added as a property to my object that was built based on that class. So indeed, if we add a field like this here, this indeed is added as a property to the object that is being created. The only difference to the constructor is that here, when you use a field like this, it's not as obvious that you call it after super. Here, if you would try to switch this, you'll get an error. Now I will get an error that I must call super first before I try to use this. Hence, in the constructor, we're forced to write code like this. If in super, so if in the base class you try to do something with name, you would therefore fail. If I add a constructor here, and I try to console log this.name in the constructor of the base class, you will see that this prints undefined. And if I would try to do something with it, like call a method on it, we would get an error that this method doesn't exist on undefined. The reason for this is that this here is added as a property in the same place as these properties are added after the super call finished. And that's an issue we faced in the last course module, where we essentially tried to use something in the base class, which was set up as a field here in the subclass, and which therefore didn't exist yet. So that's something to be aware of. But generally, what you set up as a field here is translated in such a property assignment that works in the same way as it would work if you would add it here in the constructor like this. So this is basically equivalent, you could say. Now it changes when we have a look at the method though, as you can already see. For methods, as we investigated before, the interesting thing is that the method itself is not part of the person object. This object only has the two properties. This method is not part of it. Instead, the method is part of its prototype. So this prototype was added automatically, so to say. It's that default prototype, which then in turn also points at yet another prototype which holds our base class object. So we got two prototypes instead of one, which you might have expected based on our inheritance. Now this setup is a setup JavaScript does for us, so to say, for a good reason. The idea here is that when we create instances of person, we want to have different property values. Here, actually, all persons we create have the same name and the name age because it's hard-coded in the class, but often you want to assign different data, different values you store in your objects. Now, methods, on the other hand, typically are the same across all objects. The logic you have in here might refer to your data, but it does so in a way that, well, different data is reflected automatically because we didn't hard code the data in here. Instead, we refer to the properties, which in turn might hold dynamic data. So the function logic typically does not change from object to object. It typically is the same. And therefore, JavaScript adds a little optimization for us here. By adding the method to a prototype, it makes sure that whenever we create a new person object, we use the same prototype fallback object. It's a little optimization which leads to less objects being created, which means less memory usage and of course less performance, because creating objects costs performance. So less performance impact, I should say. And I can prove this to you. If I create another object, P2, another new person, and now we check if the prototype of P is the same with the triple equality operator, not that it would matter with objects, but anyways, then you will see that we will get true here as a result if I reload this. We get true because they're using the exact same object, not an object that's created in the same way. No, the exact same object in memory. So by adding that method to that exact same object, we can share that object, and hence it only needs to be created once, even if we add 100 persons. So that saves memory and performance. So that's a little optimization we get here when we add a method like this. The equivalent, if we would build it on our own, therefore would be that we don't create a constructor function like that, where we set up this as a property in the constructor function, but that instead we add it here on the prototype of our constructor function. So on this blueprint for the fallback value, so to say. If we do that, then we make sure that greet is only created once. It's created here when JavaScript executes this code block, when it executes the script. And thereafter, whenever we build a new object, a new person based on this constructor function, only this code is re-executed over and over again. Only these values are recreated over and over again This function is not recreated. Instead, every new person just gets this prototype assigned and therefore has access to this function. So this here is basically equivalent to this setup here, you could say, without the extends keyword. So now this class is equivalent to this setup down there. That's what JavaScript does for us, and that's a little optimization. Now the code we had before, where I added greet like this here inside of my constructor function, could also be rebuilt here in my class. Option number 1 is to go into the constructor and here say this greet equals function something. Option number 2 is to use a field where you don't use the method shorthand, because that method shorthand is the trigger for JavaScript to do that optimization, but instead you use an equal sign here and then assign a function. And it doesn't matter if it's an arrow function or a function created like this. If you do that, if you create that method like this, you can call it like before. You'll not see a difference. If I comment this normal constructor function out and I go back down to my code, pgreet will work. This will work just fine. And by the way, I now also have to remove super because I'm not extending anything anymore. But this will work just fine. If we reload, we see that output here. But technically something different will be happening here. If I console log p here, you will see that now in that object, greet is part of this object itself, no longer part of the prototype. And that means that this function here is indeed created for every instance of this object, every instance based on this class. Now that means that we occupy more memory, and a creation of such an object, of course, also costs some performance. Now it of course depends on the app you're building. In many apps that might not matter a bit, because whenever I say it costs performance and it occupies memory, of course I'm talking about milliseconds or less of performance impact and of kilobytes or less than kilobytes of memory impact. So we're not talking about a huge impact. So doing this here is not necessarily false or super bad. I just want you to understand that there is a difference, and typically you might want to avoid doing that. However, a common use case where this can be helpful is if you use an arrow function here, because then this will actually guarantee you that this in there refers to your surrounding class. So if you then, for example, bind this to an event listener or something like that, this can be easier than using this more correct syntax, where you then have to use the bind method to bind this correctly when assigning this to an event listener. That's a small scenario where this might be good to use. This plus bind will actually still be a bit better from a performance perspective, but due to the better readability this approach has, versus this plus adding bind on some event listening code, might lead to this being used despite it being a bit worse. But since the performance and memory impact is so marginal, if you're not building hundreds or thousands of persons, it might really not matter, and then using this might be beneficial. Here is the example I meant. If we have some button, which I get by ID, btn let's say, and then we add an event listener here, a click event listener, and we bind this to p.greet, and I quickly add this button here to the index.html file, greet me, then you will see that with this button and the event listener added, if I use this arrow function syntax and this syntax where I store it in a property instead of using the shorthand, and by the way, in case you're wondering, no, the shorthand is not available for arrow functions. So if I use this syntax, you will see that it works. Just one thing before I forget it. Of course, I need to add that btn ID here to the button. So let's add that. And now if I add this and I run this code, reload here, you will see that if I click greet me, this works as we would expect or how we would want it to behave. And now, this is what I meant. If we instead use the more correct shorthand here, this will not work, because this will now refer to the button and not to the class, because of how event listeners work and how this works. So here you see, hi, I am and I'm undefined years old. So this is then the part where you could, of course, use bind here, and here not bind this, but bind it to P, so that this inside of greet refers to P. This would work, and therefore if I save that, of course, that is a perfect alternative. We get the desired result. But this is a bit harder to read, so you might prefer this here. But it's personal preference, of course. Bind here takes a bit less performance typically than using this approach. So this plus bind is preferable, but that is something you can use if you're not creating thousands of objects. Here's a summary, which you also find attached. For creating methods in classes or in constructor functions, we got 3 different ways. We can use the method shorthand in classes like this, and this will then automatically by JavaScript be assigned to the prototype of person and be shared across all instances, hence it's not recreated per instance. Or we use a property function or a property arrow function, which also helps us with this. A normal property function will not help us with this. A property function would look like this in a class, a property arrow function like this. Alternatively, you can always also add it in a constructor function as shown in the constructor part of these code snippets here. And here we of course create a new function for every object, which is also why we get help with arrow functions and this. And therefore this might be helpful, but again, it costs some performance, so it's typically not recommended. But if you're not creating thousands of these objects, it should be fine in most applications. So just something to be aware of. More important, of course, is that you generally understand the idea of prototypes and what JavaScript does there and what classes and extends and so on does for you there. Now, one important additional word about prototypes in JavaScript. They're essentially everywhere, and we have also taken advantage of them in the course already without knowing that we did so. For example, with all the array methods I explained to you. If you dive into the MDN docs, you see that the array methods, concat or filter, are actually part of array.prototype. So they're defined on the fallback object, on the prototype, every array is connected to. So when you create an array with the square brackets, for example, you automatically get an array object, which itself does not know these methods, but it knows its prototype, which in turn is an object that holds these methods. And here, of course, you also find all available methods on that prototype, including some methods which I didn't have a closer look at in this arrays module. And it's not just arrays. It's also the case for strings, for example. Now, strings are kind of a special type because they're primitive values, but as I explained, they still kind of behave like objects when you do call a method on them, some JavaScript internal. And therefore, here we also got a string prototype, which is then utilized in the end, which holds methods that help us with strings. Something like slice, for example, which we also know from arrays, but also string exclusive methods like replace or split, which we saw in the array course section. And that's in general a pattern you'll see throughout JavaScript. There are a bunch of built-in objects which are used as prototypes, so as fallback objects, for other built-in objects. I'll sporadically come back to that and dive into this when we need to know it. For now, just be aware of that and be aware that this is a core part of JavaScript and that it's important for how fallback, methods, and dependencies and shared code is managed in JavaScript. So that's almost it for prototypes and constructor functions. One thing we hadn't had a look at yet is how you can actually change the prototype of an object which already was created or which you are not creating with your own constructor function. So here for person, for example, we clearly can set the prototype with person.prototype, or to be precise, we could set it to a new object, or as we do it here, manipulate the default prototype. But what if you already have an object and you somehow want to change the prototype after it has been created, or you want to create a new object without your own constructor function for whichever reason, and you still want to set a different prototype. Now, let me make it clear that both cases are definitely niche use cases, very advanced use cases. You might not encounter them every day, but you will certainly find some scenarios where it can be useful if you are able to change the prototype of an existing object or of an object which is not created with one of your own constructors. So let's have a look at that case here. And for that, actually, I'll comment this here out, just so that the console isn't cluttered too much. And let's create a new object here. Maybe to mix things up, name it course. Now, course is an object which I create here with the object literal notation. An alternative would be to use new object, this built-in object constructor. But I'll use the literal notation here. And now in there, let's say a course has a title, JavaScript, the complete guide, and also a rating, which of course is 5 here. So that's my course. And now here, I want to call print rating. Now that should output some information about the rating of the course. Unsurprisingly though, if we reload, we just get an error that print rating is not a function because it's clearly not a method defined on this object, and the prototype of this object also won't help us. If we comment this out for a second, if we console log course.__proto so that we can have a look at the prototype that is assigned here, and we reload, we see that is in the end a prototype which has a constructor function, which has 2 strings. So it's that default object.prototype thing we already learned about. So that doesn't help us. We would want to adjust that prototype. And we want to do that after the object has been created because, well, it clearly has been created already. We can do this with the object constructor function here, the global object constructor function. And there you have a get prototype and set prototype method. Now let's first of all have a look at get prototype off and pass in the course, and then let's console log the result of that. Just like that. So now I'm using get prototype off of my course object. If we reload, we get exactly the same output as before when we accessed __proto. This __proto thing in the end is just a unofficial feature which was implemented by all browsers actually, but it's not really the way you're meant to work with prototypes in JavaScript. It's just due to the evolution of JavaScript and that certain methods of interacting with prototypes weren't always available that we have this special __proto__ property, which indeed can be useful for looking into a prototype. This here would be the more official way, but of course it's also a bit longer. So you wanna consider using that in code you write, where you really need that logic as part of your code execution. If you just wanna look into the prototype during development, definitely use __proto. So that's get prototype off. More interesting for us here is clearly set prototype off. This takes 2 parameters, and the first one is the object where you want to set the prototype, so my course object here. The second then is a prototype you want to use. And that's the interesting thing now. Here you can override the prototype that has been assigned to an object after the object was created. And of course this works on any object. You can override the prototype of any object, including objects that were created based on your own constructor function. And here, for example, we could then add a print rating method like this, and there output some string here where we say this.rating and then maybe of 5, so /5 thereafter as a string. And thereafter we'll see that this line should of course work because we set the prototype, of course, to something new. If we now reload, this output works and we switched the prototype. If you would want to keep the original prototype and only add something to it, you could of course use the spread operator here and access object get prototype off course. This is a valid use case for the get prototype off method now, because this is not just some quick hack we're using to look into the prototype. It'll be part of the code we ship to our end users. So here I get the current prototype, spread its properties into my new object, which will be used as a new prototype, and then add my own print rating method. So this would be a way of making this work whilst keeping the old prototype object functionality. Though it's also important to keep in mind that since we set the prototype to a new object, that new object, which we set as a prototype, will have its own prototype, which is also object.prototype. So actually, through that entire prototype chain, we would have access to toString and so on, even without that line here, because this object, which we set as a new prototype, will have that default object.prototype itself, and we would be able to access anything on that prototype from our course object as well, thanks to that prototype chain, where we always go to the next prototype in line if we can't find a certain property or method on the given object. So this is how we could set a prototype after the object has been created. You can also set the prototype for an object which you are creating, even if you're not creating it with your own constructor function. For your own constructor function, you can adjust the prototype like this here before you create your own objects. Now, if you for some reason don't want to use your own constructor function, you can also create, let's say, a student object here, not with the object literal notation and also not with new object, but instead with a new way, which I haven't showed you before, where you use object.create. This will actually also create a new object, basically just like this does it, the object literal notation, but with a twist. Now, object create takes a parameter, and as you see, it takes an object as a parameter. Now, that's not the object with which it will initialize the object it creates. Instead, it will basically create an empty object. The object you pass here as a parameter will be set as a prototype for this initial object. So here we could add, let's say, a print progress function where I console log this dot progress, clearly a property which I haven't added anymore. And now if we console log student, you'll see that if we reload this application, student is an empty object, but it has a prototype which has a print progress method. So the object you pass to create is set as a prototype for the empty object create creates otherwise. If you then would want to add something to that object, you can do that by using the dot notation here, of course, for example, a name, max, or of course also with the define property method we already learned about earlier in the course, where you can add a property to an object, so to student here, let's say the progress property, which you then also can configure with such a descriptor object, where you have configurable, maybe set this to true, enumerable, maybe set this to true, a value of, let's say, 0.8 to have 80% progress kind of, and then also here writable, maybe set this to false, whatever you want. So these are different ways of adding properties to an empty object. The important thing is that object create does create such an empty object, but it does create it with a prototype of your choice. Side note, object create also takes a second argument, which would take such a property descriptor map, where you then also could add properties like that in the creation process if you want to create a non-empty object. So let me comment that out. Here in this object descriptor map, you could also add properties like name and then have an object for every property you want to have added to this newly created object, where here each object has to describe a property exactly like we do it down there. So here you can also add configurable, false, or maybe true, enumerable, true, value, max. The value for the name property will be max, and writable, true. So that's an alternative to that, and thereafter I'll comment that back in so that we also have a progress. And these are simply different ways of creating objects. Obviously, not always the ways you'll use all the time because they're a bit more complex, but they also give you more features, therefore, more flexibility, more power, and hence you should definitely be aware of these object creation methods as well, and of object create in specific because it allows you to create an object with a different but the default prototype assigned right from the start. So now just to verify that everything works, let's reload this and we output the progress here and we see this is the object that was created. So that is all working. And with that, we learned a lot about prototypes and objects and how to create objects, I guess. So that is it for constructor functions and prototypes. A core concept, you won't have to write this code a lot, or actually that depends on the job you're on, the project you're on. You might end up in jobs where you have to write that code. But in modern JavaScript, you typically work with classes, you can extend other classes. Still, under the hood, as I showed you, this embraces this prototype concept, and you need to know that. You need to know that because it helps you implement performance optimizations like this one, or use the proper syntax there, at least be aware of it, that's already a plus. And it also helps you ace your interviews and in general get a feeling for the language you're working with. You don't just want to copy and paste snippets, you want to understand what's happening behind the scenes. And in this module you learned that classes are in the end syntactical sugar for prototypes and constructor functions. Though, very important, let me come back to that slide I showed you earlier regarding constructor function versus classes. There also are differences. Differences which you at least should be aware of. Constructor functions are these functions which you can call with new, so that they don't behave like normal functions, but differently. Now, classes actually have to be used with new. If you try to call a class without new, it'll just fail. Another difference is that when you create an object with the help of a constructor function, all properties and methods are enumerable by default. Remember, at the end of last module, I had a look at object descriptors and I showed you this idea of enumerability and how you can turn it on or off and how that affects what gets used or what gets output in a for-in loop. For objects based on these old school constructor functions, if we want to call them like this, every method is treated as an enumerable property. For classes, that's different. Their methods are non-enumerable by default. One other difference which I want to highlight is that constructor functions by default don't use strict mode. You would have to turn it on. Classes, on the other hand, do use strict mode. So all behaviors you have in strict mode, you have that turned on in classes out of the box. Now, these are all not the most important things to know. The thing regarding methods not being enumerable is probably the most important one, but still, for completeness, combined with all the other things, this is what you should take away from this module. And with that, you're well prepared to work with classes, to inherit, to extend, to work with properties and methods, and you also have the theoretical foundation to understand what's happening behind the scenes.